Welcome to the session on AI for FinOps. A lot of exciting content here, so let's start off. In this session, you're going to see we're going to go through three basic themes you've been hearing about throughout the conference, as well as maybe for a few years before this, that FinOps is shifting left, coming in earlier in the software development lifecycle. We'll go through a concrete example and show how that gets manifested. Also, we'll show you some workflows in how to operate and optimize with Azure Copilot and the agentic workflows in Azure, as well as how you can analyze and report at scale, bringing in operational data and organizational data together to analyze the data. So let's get started. As agentic workflows are becoming more prominent, the key areas of focus are to empower you to build apps, agents more efficiently. You're already probably seeing agents accelerating delivery. We are seeing agents freeing up time for innovation, as well as helping with operational workflows at scale, and changing the playbook for modernization. Tech that used to take years are now becoming more of a reality to actually reduce it, eliminate it, and that we're seeing it across the stack. So innovation at the speed of AI. So what does this mean? Every individual in the organization, every persona has different tools that they can use. And these are just some sample sets of personas who are benefiting from the advent of AI. It is helping individuals and teams from going and showing what they can do with the capabilities they have in hand, and not just by the effort that they need to do it. At every stage of the software development lifecycle, you'll see that humans and agents are collaborating for the jobs to be done. Software is helping you express the intent. More and more of the manual tasks are getting automated, and expertise itself is getting democratized. The context that is available with agents is helping everyone become a builder. So this is innovation which has never happened before, and with the context that agents have, building apps is even more efficient and easier. So as we're going towards one of the, how we are building with AI, you'll see that developers now are going from an AI-infused workflows to an AI-native workflow. You'll see that the value is being seen across the software development lifecycle, not just at the development stage, at the operation stage, change management, optimization, name it, and the value is coming through. I'm going to go into a demo which actually shows how FinOps is shifting left. Before we go there, I'm going to start with what we are building. The frameworks that we are building MCPs that can access cost APIs, pricing APIs, the tool sets required for agents to actually be built and agents to get context. In addition to the MCP servers, we have skills that are samples for agents to operate on to direct workflows in a way where agents can do the task at hand more efficiently. And add to it is the ability to export both operational data, cost data, organizational and business context into data lakes with Microsoft Fabric, where you can analyze at scale and understand how operations and business context is coming together. So that's what we are building from a framework perspective. What about the tools that are on top of it? Depending on the personas, you have different kinds of tools, starting with IDEs, CLIs, workflows in Azure Portal, M365 Copilot, Power BI. All of these tools are available today for you to try out, from building an app to analyzing an app or analyzing your workflows. So let's dive deep into a demo. And this is going to be an example where, as FinOps shifts left, embedded into the software development lifecycle in the various stages. While you're building the app, what are the considerations? While the app is getting deployed, what are the other considerations? And as the app is running in a stable state, what about change management, optimization that you need to go through? The format of this demo is going to be, I'm going to show a prompt in GitHub Copilot that we ran. And from here, the output is the value that agent is bringing into the developer workflows. This is more focused towards the FinOps workflows, but it is a broader app development that we are showing through the GitHub Copilot CLI. So this is a sample prompt where you're starting with a budget that has been approved. Of course, the analysis required to come up with the budget has been done offline. And at this point, what are the services that can be fitted into this budget for the architecture that is being proposed? So here is where it starts with. The response that comes from is, the first step is estimation, and estimation of the services that will be used to deploy the application. And while the services are being suggested or recommended, the first thing that happens here is looking at what the organizational policies are for that set of services. The organization policies may be related to cost, may be related to governance, related to geo-governance, or could be related to performance characteristics that the organization has standardized on. So in this particular case, the agent is running and accessing Azure policy and getting the approved SKUs for this workload. And the next step after that, once the approved SKUs have been determined, the next step in the estimation process is finding out the cost. And the starting point or the default point for getting the cost is through the retail APIs and the retail workflows. If the one thing you'll notice here is the agent is giving the cost right here in the workflow. Typically, otherwise, what you would have done is get the SKUs, find the services, either call the APIs or go to Azure Calculator or pricing pages and come up with an estimate. So this makes estimation really easy and part embedded in the workflow itself. As I mentioned, the starting point here is the retail prices. But at the same time, the agent has a way to get your organizational prices too. This depends on the access that the user who is running the prompt has. So in the context of the user, the access is being determined both from an access point of view as well as understanding the cost policies. Things like, can you see the negotiated prices is being determined as part of this workflow. So assuming that the user here has access to the workflow through the negotiated prices, the price sheet gets downloaded, and now the prices are shown both at the retail price point and the negotiated price point, and the discounts that have been negotiated before. This is showing both validating the discounts as well as showing some of the value that you're getting with the negotiations that have within the organization. And translating that into the actual cost of the services and showing the savings associated with that. So cost estimation is the first step, and it's get embedded right into the workflow with a simple prompt that you start with. Now that you've got the cost, at this point, you have deployed the services, or you're in the process of deploying the services. And one of the things that you should be doing is proactively managing cost. And the reason of proactive cost management here is that you don't want to understand cost overruns when that happens. The best practices here are configuring things like Azure budgets. Azure budgets helps to make sure that along the way, as the services are getting used, what are the cost impacts and the cost trends, and is the service running within the approved cost limits? So at this point, the agent is connecting and finding out through the budgets API what kind of budgets can be configured. A tiered structure of budgets is recommended, wherein, depending on the hierarchy that you have configured, have costs at the highest level of the hierarchy, which is subscription or even a billing account, and then go to the levels of the app, tags, and understand the impact of particular services whenever there is a budget overrun. And as the budgets are being configured, one of the patterns here that the agent determined also was that budgets can be configured at various thresholds. So understanding the cost at different points in the cycle, like let's say a 50% threshold, a 75% threshold. And the cost itself could be actual or forecasted. And having it based on forecasted gives you even more proactive cost management, which would be a good thing if the cost suddenly spikes. You have to remember that there are some latencies associated with costs, so having a tiered structure helps to overcome some of those latency impacts that comes with the cost flowing in latently. So from here, the agent goes and configures the budgets, and now the budgets have been configured, and now the application could be running in steady state. At this point, as time passes, the budgets could get triggered because of various reasons. And it usually starts with the flow where you get notified that a budget has been triggered. And once the budget has been triggered, in a usual workflow today, you would go into Azure portal, go into probably the cost analysis workflows, or any other tools that you have in hand to understand what resources contributed to the budget increase. In the workflow that we are showing, this step can be, the investigation can be triggered right from the prompt itself. In this case, to start the investigation, we're trying to find out what the cost increase was at the namespace level. Here it starts with determining which subscription had the cost spike. What was the budget alert that got triggered? And this is the first point. The next point that comes out here is that how much cost increase was there, and is it within the approved budget? So even though there was a trigger, the budget is within the overall approved budget. So understanding why this happened and probably rectifying it before it goes over the overall budget is the recommended pattern. From here, you can go down to the services. All this with this one prompt, you're getting a response. So this prompt, now the next level of the response is the virtual machine scale sets was where the cost increased. And further investigation shows which service or which namespace had the cost increase. So here you're seeing a combination of the cluster cost and the AKS-specific namespace cost coming together and showing where the cost increases were there. And from there on, the power of the agent comes in here to show that now you know the cost increase. Cost data shows you that the cost increased. But why it increased is still a level of investigation that you would have to do. You would need to find out, were there any resource changes? Was there any deployments? All of these are things that are available through either the portal or through APIs. But doing that investigation or troubleshooting is generally more complicated. In this case, with the skills that we have, the agent figures out that let's go and find out what the cost increase was through the Azure Resource Graph, and from the Azure Resource Graph, find out what actually was happening beyond just the fact that the cost increased. In addition, there is access for the agent to the application metrics. So combining resource changes, application metrics is also important to understand. Is this a planned change? Is this a change that is actually because of maybe organic growth? Or is this something that should be rectified? So I just showed you two examples here. One example where in the first case, we saw that the cost increase was because of an increase in the requests. The increase in requests triggered a auto-scale event. The second one was also a cost increase, but the metrics are showing that even though there was an increase in cost, the utilization metrics are showing that the resources are not underutilized. So further investigation on this can be done through the integration that GitHub Copilot has with your repos. From the repos, it can pull in what was the change history. In this case, the case for auto-scaling or scaling was done as a check-in that may not have been a valid check-in too. So here's the power of the agent that comes in, which is combining cost data, resource changes, you're connecting to your CI/CD pipelines, and coming up with the analysis of why something happened. And now you can make more informed decisions without having to navigate through a set of experiences and a set of APIs to come up with the same conclusion. Now, as the app is running in more steady state, you may want to find out optimization opportunities. Optimization opportunities generally start with finding out who are the top contributors and how can you optimize those top contributors. The traditional workflow here is going to Azure Advisor and getting the recommendations. And the agent is doing exactly the same. It is going to the Azure Advisor, using the APIs, getting the recommendations, and both the usage recommendation and the rate optimization recommendations. But here's another case where the power of the agent comes in. In addition to that, the agent is also querying APIs of existing reservations and savings plan. So in that case, it is overlaying a usage recommendation with an existing savings plan or RI, and the intelligence is being overlaid here to say that if that recommendation was actioned on, an existing RI could be underutilized. Now, this overlay or this insight, you could have found it, but again, it would have been a complex investigation, or you would have realized this only after right-sizing the workload. From here, the agent can, with all the data sets and data points, it can reconcile the recommendations and give a unified set of recommendations, which is across both rate and usage. Now, one of the other things that the skills that comes with it also does is that you can look at recommendations beyond just the right sizing and workload optimizations that are in the advisor. The skills have been also trained with capabilities for other services. Example, in this case, the skill is looking at storing metrics and determining that is the blobs or storage being accessed as planned. So one of the features that is there with storage is smart tiering, where depending on the access patterns, you can automatically, the system will automatically move from hot to cool to cold. But without turning this on, the default would be, let's say if it was a hot tier, you would remain in hot tier and be spending more. So this is another example of knowing what are the available options for cost optimization. And after you've done with this, one of the steps here is how do we operationalize this recommendation? What the agent does is it creates or modifies the infrastructure as code scripts. It gives an optimization plan that is generates a PR because it's connected to your GitHub repository for humans to approve. So some of these actions with the agent are, I wouldn't say they could have impact like performance. They could have cost impacts if RI or savings plans are purchased. So the eventual action that results from the optimization recommendation is coded into a script, a Terraform script in this case, which could be approved by a human to take that action. So at this point, you look through some of the capabilities in the GitHub agent. And what goes underneath that to make this happen is something that we'll go through now. I'll let Hande go through some of the details of things that are available today and things that you can use to make these things happen.
Thank you, Vikram. So Vikram just walked us through 4 scenarios: cost estimation, budget setup, cost spike investigation, and an optimization that ended in a pull request. I'm going to spend the next few minutes explaining the architecture behind it, what we shipped, how you can extend it, and the design principles we recommend. We are seeing a shift in the FinOps industry right now. The cost decisions are moving out of the static dashboards into the developer workflows. And agents are becoming the orchestrators of these workflows. And what we built is a direct response to that shift. Let's start with Azure Resource Manager MCP server. Our cost management and pricing APIs are Azure Resource Manager APIs. And we expose them as tools through this remote Microsoft-hosted server. Because the server is remote, once you install it, there's nothing to keep up to date. All the new tools and updates ship to everyone the moment we release them. The server also gives you tools for Azure Resource Graph, for querying Azure Resource Graph, and for deploying Azure Resource Manager templates. And those work hand in hand with our tools. In the demo, we saw that the agent was querying Azure Resource Graph alongside with our cost tools. There's one principle we kept in mind when we were building this server, which is treat your agent's context window as a budget you need to optimize rather than a limit you cannot exceed. What does that mean? It means that every tool you put in front of an agent is going to spend tokens and going to compete for its attention. So if you give it too many tools, it's going to be slower, more expensive, and likely to pick the wrong tool. So to keep the server lean, the cost management and pricing tool sets are disabled by default, and you enable them using the toolset headers when you need them. The second piece we're shipping is skills. Our skills are basically markdown files that describe a workflow, which tools to call, in what order, when to branch on a condition, and when to ask the user for a clarifying question, and how to reason about the results. Everything we saw in Vikram's demo was a skill: the cost spike investigation, optimization, and the estimation. We saw in the estimation workflow that it started with Azure policy to find the approved SKUs. And then it went into retail pricing. It asks the user whether they want to download their price sheet, and it reconciles that negotiated rates. That ordering and judgment lives in the skill, not in individual tools. And skills generally sit one level above the tools orchestrating them. These skills that we're shipping are samples. They're there to show you how the MCP tools we're shipping can be orchestrated. So our recommendation is adapt them to your own workflows and write new skills. And the same less is more principle applies here as well. Only install the skills that you actually need and keep each skill lean. What we're looking at here is the interactive path. There's a human in the loop asking questions, making decisions in real time, with the agent pulling trusted cost data via our governed MCP server to answer the questions. It is the path we just saw in the CLI example Vikram walked us through. If we look at the MCP server box, you'll see that the tools are grouped into tool sets. The cost and pricing toolset gives us cost and forecast, budgets and alerts, commitments and pricing information. And right next to it, we see the Azure Resource Graph toolset, which helps us query ARG to find information like Azure policies, advisor recommendations, and resource changes and history. In the example, when the agent checked for Azure policy for approved SKUs, or downloaded our price sheet, or grouped Azure Kubernetes cost by namespace, each of those were separate tool calls. And the server itself is stateless, so we're not storing or caching your data in anywhere. Every call runs on your behalf with your token against the same Azure Resource Manager APIs Azure Portal uses today. The agent inherits whatever access you already have, whether that's your policies or Azure RBAC. So if a user cannot view cost in Azure Portal, neither can their agent. Now, once the agent has these MCP tools available to it, it will start connecting the dots using the skills. Let's take the cost spike investigation. It crossed 4 different systems. First, our tool queried the Azure Kubernetes cost by namespace. Then Azure Resource Graph showed the virtual machine scale set sizing changes. Metrics showed the GPU utilization. And finally, a separate GitHub MCP server found the commit behind the cost spike. The skill told the agent how to orchestrate these different systems and connect them together. And because MCP is a standard protocol, you can plug in more MCP servers in your skills if you like, such as an MCP server that can query your data lake that contains your business metrics. The interactive agent is great for ad hoc questions, cross-system investigations, and judgment calls that require workload context, exactly the situations Vikram walked us through. But for large-scale analysis, such as like running unit economics across a full year of focus data, scanning every reservation across hundreds of subscriptions to find renewal candidates, or building recurring executive reports. The right place to do these things is in a data lake. For those workloads, our recommendation is export your cost and pricing data alongside with your business metrics into Microsoft Fabric and run the analysis there. And now I will hand it back to Vikram to show you Azure Copilot and Microsoft Fabric solutions.
Thank you, Hande. So Azure Copilot in the Azure portal, we have had these capabilities for Cost Assistant for some time now. In fact, we launched this 2 years ago in FinOps X, where the Cost Assistant capabilities has evolved here. And Azure Copilot itself has capabilities for purposeful built agents for the various functionalities that you can do within the portal. So it is a chat interface to begin with, to get starting with cost investigations, but there are capabilities here to create views, as well as understanding what are the optimization capabilities or optimization recommendations available. Again, you start here in the portal with Advisor and look at the recommendations there. What you'll notice here is that in the Advisor, there is more capabilities to understand the recommendation itself. In addition to the recommendation, it gives what is the impact of the recommendation, what is it today, and what is it if the recommendation is accepted. So this is the power that the agent is overlaying on top of the existing functionality to make it more clear of what are the consequences of the changes. One of the things we are introducing is a concept of a Copilot workspace. This is brand new and something that is coming in the next couple of months. I'll have a sign-up link in the deck itself later on. But this is a way where related resources can be grouped together to get a shared outcome. So the workspaces allows you to put related Azure resources and get insights related to those resources. An example here would be a telemetry data, cost data, and actually business metrics coming from your databases. All of this together can be seen in one dashboard, and intelligence can be overlaid on top of that. This is still early, so it is something that is coming in the next month, a month or two. So I encourage you to sign up. The sign-up link will come at the end of it. We talked about workflows through GitHub CLI, Azure Portal, and what about reporting at scale, where you want to bring in operational data and organizational data or business context. All of this starts with exporting the cost data from the Azure portal. We have been supporting Focus format exports since the launch of Focus. And right now, it is at 1.2. But we are planning to support 1.4 in the next couple of months. This data, once exported, can be imported into Microsoft Fabric, which is a single data lake where cost data, observability data, and you can bring in business context together and look at the data through reporting in Power BI. The capabilities to create reports in Power BI can be even more simplified with the Copilot capabilities that are there in Power BI, where with the access to the data, reports can be created through either few clicks or through insights that you're asking through Copilot itself. So this particular example shows the power of the data lake and the Fabric IQ that comes with it, where you bring in business intelligence through your business data, operational intelligence through the either cost or observability data, and all of this is meshed together to create a unified dashboard or intelligence that will power your analytics. So here are a few references for you. We already talked about the MCP server and the skills. The Copilot workspaces will be in preview in the next few months. The sign-up link is attached with here. So please go and sign up for this. Thank you.
Hey everyone, producer Andrew here. Thanks for watching. Check out the rest of our channel for more FinOps content. Like, subscribe, and leave questions and comments for our speakers. We appreciate your support.